Hey there, this is Jack Delora back with another TouchDesigner tutorial. In this video, we're going to have a look at the new POP family of operators and create this cool interactive op art inspired effect. We're going to have a look at the copy pop, which we'll use to create the main geometric foundation of the effect, and then we'll work with the use of our mouse position along with the field pop to create the color shifting and rotation. So it's a lot of fun and a great way to start experimenting with creating some cool pop-based visuals of your own. To start, I wanted to first mention that I'm running the experimental version of TouchDesigner, so pops have not yet made the transition from experimental to the official release, meaning that some of the things that we cover in this video may change in the future. With that said, I'm running 2025.30280 for this video. So we're going to start off by creating a blank project, and we're going to start off today's effect with a container comp. The container comp is really useful for creating interactive effects like this one, as it has some built-in functionality for interacting with the mouse and keeping track of the mouse's position in a normalized fashion. For this container, I'm going to set up the output, or rather the width and the height, to match what my final rendered resolution will be. And so I'm going to set these to 1280 and 1280. So this is going to be a square resolution. Again, that's the width and the height parameters on the layout page. That's changed the size of this container, and again will allow us to display our final render at full scale. Next up, I'm going to head inside of that component by double clicking on it, and we'll get to work on building our network. So the main component of the grid of geometry that we saw at the beginning is essentially a merged set of circle pops. So we're going to create basically one quote unquote instance, so to speak, and then we're going to create a bunch of copies of that piece of geometry with the copy pop. So we're going to start by adding a circle pop, and then I'm going to copy and paste that so that I have 3 of those, which I'll then merge together. The first one is going to be left in its default state. The second one, I'm going to adjust the radius, and I'm going to also translate its position slightly. So I want my radius here to be 0.2. So I can use the uniform scale parameter there and set that to 0.2. It's going to reduce the radius and make that circle smaller. I'm also going to translate this in the X direction by 0.1, which will move it to the right a little bit. And then finally, we're going to click on our third circle here, and I'm going to also reduce the scale of this one, but to a slightly larger scale of 0.6. For this one, I'm going to adjust the translate again and shift it to 0.35 in the X direction. Now, these all look kind of arbitrarily positioned at the moment, but if we then add a merge pop, and go ahead and right click and drag to box select all of those 3 circle pops and then connect one of them to that, you'll see that we are left with the initial piece of geometry that we're going to then copy and duplicate over and over and over again. Now that we've got that set up, I actually followed that up by adding a transform pop. So in this transform, we're going to reduce the scale via the uniform scale parameter to 0.05. So that's made it really tiny, but that reduction will make it the correct size for our final outcome today. Now, before we head into the copy pop, I also want to add an attribute via the attribute pop, which is going to allow us to add a color to each one of the eventual copies that we'll create. So with the attribute pop, I'm going to be on this create page and add a color attribute. I'm going to set this color value to white by adjusting the red, green, and blue parameters here so that we'll be able to see this piece of geometry instead of it having a black color applied. Now we need to do this now. We need to add this attribute now so that as we create copies of it with the copy pop, it will have that attribute already included as a part of the geometry. Now we're going to add the copy pop. The copy pop allows us to generate copies of this geometry just like the copy SOP, but also has some cool features of its own. In this case, we're going to connect the attribute pop to the first input, which is the data that we want to create copies of. And then we're going to need to, via the second input, provide a template. The second input, called the template input, is where we can provide a piece of geometry from which the copies can be generated. So that piece of geometry, each point contained within it will generate a new copy of this particular pop geometry. And so we're going to set up a grid in this case, because what we want to do is to create a grid of copies of our circle shape. So we'll add a grid pop. And for this grid pop, I'm going to simply take this uniform scale and set it to 2, allow it to kind of fill the space of the container that we've set up. So next up, we're going to add the field pop, which is a core component of this particular effect. Now the field pop, as we can see here in the documentation, is going to add a weight attribute that represents for each point of the input how much a shape defined by the field pop overlaps with each point. In our case, that means that we're going to be creating with the field pop a invisible sphere, which will then be overlapping with this grid shape, and then we'll be defining an attribute called weight based on how those points within this shape overlap with the sphere. We can then manipulate the position of the sphere, as we'll see with our mouse position, to cause that attribute called weight to change, and meaning that the overlapping of the sphere will be slightly different with each one of the points in this grid as we move that sphere around. We'll see all of this in practice in a moment. It'll be easier to visualize things when we can actually see it. But for now, we're going to set up the field pop parameters. And then again, we'll have to come back later and see how those results are impacting our final output. So first of all, I'm going to set the radius of this sphere that's being generated by the weight pop to be slightly smaller. Right now, it is set to 1 by 1 by 1, and I want this instead to be set to 0.4, 0.4, 0.4. I've gone ahead and done that by middle mouse clicking to bring up the value ladder, and then moving my mouse left and right while holding down that middle mouse button. Then I'm going to head down to this weight section. I want to increase this transition range so that instead of sort of having a sharp cutoff around the boundary of this field, instead we'll have a nice sort of smooth transition. And again, we'll see this in a moment when we start applying these attributes. So I'm going to set my transition range here to 1, and then I kind of manipulated the transition align parameter based on further experimentation later when I can actually see the output to a value of 0.215. Now we're going to come back to the transform page in a moment. It'll be here that we actually take the position of our cursor and apply it as chop references. And that again will allow us to adjust the position of this currently invisible sphere. Now I'm going to finish up by adding a math combine pop, which I'm going to use to create the actual attributes that I want to use in this copy pop. So I'm going to basically use this to do a little bit of math to the weight attribute that we've created here and generate some additional attributes as well. So first of all, in the copy pop, I want to point out that on the template page, you'll notice that we have all of these different parameters that we're able to pull in from the template. So these are essentially attributes. Once we plug our template into this second input, these are various attributes that we can then pull from that template and have applied or impact these copies. So you can see here when I connected the math combine to the copy, immediately we generated copies of that piece of geometry at each point within that grid. So that looks fabulous so far. But now we're going to come back to the Math Combine and start actually setting up some of these additional attributes, which we can then use to impact the copied geometry. So you'll notice here that they have some predefined names which are provided for us, and we're going to use those names in the attributes that we create back here in the Math Combine. So I'm going to head back to the Math Combine POP, and we're going to use the new page to first create the ROT attribute, which will allow us to apply rotation to each one of the copies. So I'm going to type in ROT as the name of this attribute, and then I want this to be a float, but I want it to be a 3-component float, meaning that we'll have X, Y, and Z rotation able to be applied. Great. So before we move on to our combine page in the Math Combine POP, we're going to head to the copy POP one more time and turn this template rotate switch on. And that is going to now pull in the rotation or ROT attribute from this template input and apply those rotations to each one of the copies. Now, right now, because we only have a value of 0.5 applied to each one of the components of that ROT attribute, we really are not going to see a whole lot happening in the copy POP. But I wanted to enable this now so that we can see how the changes that we're about to make will impact the output. What I want to do with the Math Combine POP now is to use the operation functions on the combine page to take the weight attribute that we created with the field POP and use that to define rotation values for these copies. Now I've gone ahead and added a pop to dat so we can have a look at this weight attribute. I wanted to showcase this now as we can get a sense of the range of the data that is being generated. So you'll notice that all of this data is going to fall in the range of 0 to 1. And that has to do with the distance of each one of the points within the grid to that invisible sphere that's being generated by the field POP. Now, if we were to just take that weight attribute and apply it directly as a rotation value, we would find, pretty similar results to what we're seeing right now, because that value is only going to provide us with 1 degree of rotation. So a handy thing that we can do at this point is to take that value from the weight attribute and multiply it by something to increase its output range. So what we'll do on the combine page is to set the operation here to A times B, and then I'm going to take the scope A parameter here. I'm going to use the weight attribute for that scope A parameter, and then I'm going to multiply weight by 360. And I'm using 360 here because I want to take the particular state where we have a weight value of 1 and change that range to be equivalent to, or to mean in the output, 360 degrees of rotation. Instead of storing the output back into the weight attribute, I'm instead going to store the resulting scope into the ROT attribute. Now, what we'll see here is something that looks pretty cool. However, you'll notice that it's different than what we had at the beginning. What's happening right now is that the weight attribute is being applied as a rotation value in the X, Y, and Z axis, which is causing these flat shapes that we've created with the circle pop to, again, be rotated in all 3 axes, which causes them to be distorted. Now, this is kind of a cool effect and definitely something that you can use with 3-dimensional shapes or 2-dimensional shapes, depending on your particular intent with the outcome. But what we're going to do today, rather than rotate in 3 axes, is to remove the rotation from 2 of these axes and instead only rotate around the Z axis, which is pointing at the camera in this case. So that means that this circle will be rotated around its center, and rather than distorting, it will just shift the position of the 2 circles on the inside. So to do that, I'm going to add another combine operation. I'll hit the plus button at the combine parameter here and set the operation for this second combine to, again, A times B. Here, I'm going to use for my scope A, ROT. And then for scope B, I want to apply 0 rotation in the X or the Y axis, but I want to keep the rotation in the Z axis. So that means I can type in 0, space 0, space 1, and that will multiply the rotation values in X and Y by 0, meaning no rotation, and it will multiply the rotation values that already exist in the Z axis by 1. So we'll just keep those values and pass them along. Now you'll see here that that has given us the effect that we saw at the beginning, where, again, we're rotating those around their center point. So rather than distorting, we're just shifting the position of those central two circles. And that gives us this kind of optical illusion type effect. So that concludes our math combine parameters that we need to adjust. And now we're going to head back to the copy pop one more time and set one final thing up here. So the copy pop has the ability to pass any of the attributes from the template through to the newly created copies as well. And we're going to use this on this template attributes page. We're going to turn this on and pass through the weight attribute that we created back here with the field pop so that we can use it down the chain in some additional operations as well. So to do this, I'm going to, again, I've turned on use template point attributes, and the one that I want to pass is, of course, weight. So I'm going to use that drop down there and grab weight. We'll now see that weight has been passed along with the other attributes that have been created by this operator. Our next step is to add color using the Lookup Texture POP. So we're going to add this after the copy pop. Lookup Texture POP here in the second column. We'll add that after the copy, and we're going to use the weight attribute that we just sent along via that template attributes parameter as our lookup attribute. So that means we need to remove, first of all, the default lookup attributes that are applied. And then I'm going to use for my lookup attribute U, I'm going to set that to weight. Now, of course, for the lookup texture pop to work, we need to actually add a texture to our project. And so I'm going to add a ramp top to generate a nice gradient texture for us. I'll add that and add a null by hitting Alt-N. Now that we have the null added after our ramp, I'm going to go ahead and reference this null in the lookup texture by dragging it onto the top parameter. Now, of course, nothing has happened yet because we haven't done anything with the output attribute scope parameter. So without this, the effect of this is lost because it's not being applied to anything. So we want this output attribute scope to overwrite our color values. And really, we don't particularly care about the opacity. So I'm really just going to write this information into the color.rgb values. So you'll notice that we have a little warning flag here, which is telling us that our incoming data, or the data that we're trying to map to this output attribute scope, actually has some extra components that are not being stored into this output attribute because there's like a mismatch in the number of components. All we have to do here is, as we mentioned, we don't need that alpha data, so we can turn this switch off for the alpha channel mask, meaning we're not including that alpha data in the output. That's going to give us a 3-component set of data, which will then be stored into that output, making that warning flag go away. And we can see now that our color has been applied to our copies and it looks great, except for the edges. So these have a weight value of 0. And what happens when that weight attribute here hits 0 is the input extend mode comes into play. So it's putting us in terms of our texture at the very left edge here. And because this is set to repeat, those specific shapes are then looping back around and grabbing a brighter color. Now, if we then set this to something else like hold, it's just going to hold that black value at the edge rather than causing that repeating to occur, and thus give us that nice smooth gradient fade to black that we're looking for. So now that we've got that mapping set up, let's go ahead and come back to the ramp for a second so we can actually customize the color that we're applying. Remember that it's important to set this type to horizontal, because if we use vertical, we end up with the same color applied to everything, because again, the lookup texture is only pulling pixel values from a single row in the middle of this texture, and it's not going to be paying attention to this vertical gradient. So again, remember, think about this as a single row of pixels. Nothing in the vertical direction will be taken into account. So we really need this horizontal mode in this gradient fashion if we want to output and get this nice gradient output applied. So really, we could set this output here to have a height of 1 pixel, and we end up with the exact same result, because again, we only need that single row of pixels to apply those colors across this set of copies. With that aside, let's add some color into the mix. So we can adjust these color keyframes in the ramp top and immediately see the results impact our output. So for example, if I take this leftmost keyframe, so if I take this hue and I enter in a value of 240 to put me in the blue range, and then play with my saturation and value to get a sort of desaturated gray blue color, we'll see that that immediately impacts the edges of the shape. We can then add another keyframe by left clicking somewhere in, I don't know, maybe around the 2/3 mark in terms of the whole length of that color keyframe selection. And then I might take this keyframe and push the hue maybe a little bit more in the, I guess, towards green, but the very light blue area, and then bring up the saturation and maybe the value as well. And you can see now we've got the dark desaturated blue, then we come up into this like kind of watery color, and then go straight into white at the end. So really you can tune these to whatever you like, pick some colors that you find appealing. But what's also cool is that these will dictate the kind of smoothness of the boundary between colors as that weight parameter or the weight attribute shifts. So for example, if I were to put a keyframe in and then move it closer together, so there's a sharp boundary between those two, you can see it has an impact, the composition that we're generating. So you can again use that distance of the keyframe to adjust the smoothness and the kind of shift of the color between one point and another. So that's actually the last step for the pop portion of the network. We're now going to set up the render pipeline, and then we'll come back around and add the interactive component. So I'm going to add a null after this lookup texture, and then I will right click on the output of the null, head to the component page and grab the geometry comp and place that into my network. Now for my material, I'm going to use the line material because everything here is essentially an outline. So this will be a great opportunity to put this material into use. So with that added, I'll drag that onto the geo component. Things will change a little bit. I need to do some adjustment in the line material. I'm gonna set the distance far to 3 and my width near to 2, which is basically going to give me the same width value regardless of the distance from the camera. The other thing I want to do is come to the line page where I'm going to turn the line near color up to 100% white instead of the current 80% white. So I'm going to click in this chooser, the white all the way on the right, brighten things up a little bit. And then I'm going to turn off specify line far color, which will brighten everything up in the geo comp. Now that I've got that taken care of, we're going to add a camera comp as well as a render top. And I also want to add a null. I'll call this null out. And then we'll come back and adjust the camera and render. So first things first, I want to set the render to have the same resolution as the parent container. I could set it to a static value, but we might as well go ahead and practice using some of our Python attributes and accessing our parent's parameters. So I can type in parent, open and close parentheses, dot par, dot W for the resolution W parameter. Hit enter. That's going to grab the parent's parameter W, which is the parameter for width of a container. And then I'm going to do the same thing for the height, except I'm going to grab dot par dot H. And that will give us a 1280 by 1280 resolution. Now for the camera, here I'm just going to set this to a static position of 2.6 in the Z axis, which will pull the camera towards our shape. So I'm going to enter in 2.6, and you'll see that if we were to right click and hit view, that pulls that shape nicely, or the geometry nicely into view with a little bit of a border around it. So with that set up, let's go ahead and, well, first of all, save your project if you haven't already. And then we're going to update our container components parameters. And then we'll add in our chop network to make this interactive. So with that, let's head up a level in our project by hitting the U key on the keyboard. And what I want to do here is to set up a background top on the look page. So I've clicked on my my container component. We've headed over to the look page, and now I'm going to provide a background top to display in the viewer. So for this, I set up that null previously, so I can type in ./ which is going to put us within this operator. We're looking for a null out. So the operator's name, again, I set to be null out. So when I hit enter, we should then see that texture in the viewer. If you didn't name it null out or called it something else, you would just enter that name in there. And as soon as you make that reference, it should appear in the background. Now, what is cool about the container versus using something like the mouse in chop is that the container is part of what is known as the panel subset of components. And the panel components have a great chop called, you guessed it, the panel chop. And what is great about the panel chop, as we'll see in a moment, is that we can get the position of your mouse over that panel in a handy normalized value. So what I'm going to do here is in this panel chop, I want to select the channel called two channels really, inside U, and then I also want to grab another one called inside V. If I were to right click and choose open parent viewer and move this to the right, you can see that as I mouse over this container's viewer, we get the results in these inside U and V channels, which again are normalized between 0 and 1, which means that no matter what the resolution of this viewer ends up being, my values are always going to be in that range, which makes it a lot easier. We don't have to map between different aspect ratios or scales or things like that. We'll always have this uniform value that we're expecting out of this operator. Another cool thing is that when we move the mouse outside of the viewer, it stops tracking the position. So, if you move onto a separate window, it doesn't impact the results here in our panel chop. So, two cool things about this particular setup. Now what we're going to do is use these values to adjust the transform parameter that we talked about a while ago on the field pop. And this again is going to adjust the center point of this invisible sphere shape that we can now see the impact of over here. So the sphere that is creating this color shift and the rotation has that center point right at the center of all three axes right now. But if we were to adjust these translate parameters, as you can see, when I move this in the X direction, it causes that color application to shift. And if we were to zoom in, the rotation of those shapes shifts as well. So here we're really seeing a visualized version of that sphere that is being generated in the field pop and also then being converted into that weight attribute. You can also see while we're here the difference that the transition range parameter makes. If we change this value back to 0, we can end up with no transition range at all, meaning a sharp cut between the weight parameter being at 1 and the weight parameter being at 0. And then as we increase that, we can end up with this nice smooth gradient. So lots of creative ways to work with this operator. And this is a great way, again, to visualize how those parameters actually are impacting the results. But anyway, we want to interactively control the translate parameters on the transform page. Before we just make a direct chop reference from the panel component, let's take into consideration the range of these translate parameters. So to have our sphere centered in space, we want the translate parameters to be all set to 0. And we can then also kind of experiment and find that to move the center of that sphere to the right edge, we need to have a translate in the x-axis of 1. Likewise, if we move it to the left edge, that will require a translate value of -1 in the x-axis. And if we remember our discussion about the panel components inside U and V channel outputs, these are going to give us values between 0 and 1. So because those ranges are different, we need to essentially change the range of this data to match that -1 to +1 range that the field pop is expecting. So we're going to use our handy math chop to do that. And I'm going to head to the range page. And all I need to do is set my to range to fall between -1 and +1. The from range is already set correctly because remember, this data is by default in the 0 to 1 range. So we've got a new output range of -1 to +1, and that will give us correctly ranged data for the parameter that we're trying to manipulate. Now, another nice thing to do here is to add a little bit of smoothing to this translation. And let's go ahead and make the chop reference first, and we can come back and add that just to see the difference. So I'm going to add a null here, and we'll call this null transform. And this will be the operator that we use to make the chop reference to the field pop. So I'm going to click on my field pop, then I'll activate the viewer of null transform, left click on inside U and drag, let go once I hit the translate X parameter, choose chop reference. And then likewise, I'll do the same for inside V, keep holding until I get to the second parameter here, make a chop reference. Now I'm going to right click and choose open parent viewer, and we'll see that we now immediately have interaction. So this looks pretty cool. You'll notice, however, though, that as I move my mouse quickly, the shapes kind of jump around a little bit in their positioning, and we can impact that movement by applying some filtering or smoothing to this data. Now, this is, of course, not necessary, but just kind of a nice thing to throw into the mix and, again, show you how it will impact the results of our copy pop transformations. So if I right-click on this cable connecting math1 and null transform and insert an operator, and then choose filter, you'll see immediately we get this nice, like, smoothing applied to that position. And so as I move the mouse around, it kind of follows me more smoothly, and we don't have any of that jittery kind of fast motion. Now, I found that in the filter parameter settings, or excuse me, the filter chop settings over here on the right, I liked using this box filter type, which gave this kind of a look as it moved around, but feel free to experiment with other types as well. The lag chop is also a possible alternative for this operator. And of course, you know, we don't have to use the mouse at all. This could be connected to the output of a Connect or any kind of data source that you can think of. But the point here is that taking this simple two-dimensional data point, our X and Y position of the mouse, and then adding a little bit of filtering and using that to manipulate the field pop's transform can give us this really cool effect. So that is it for our video today. I hope that you have found this useful as you're trying to start wrapping your head around the new POP family of operators. As always, make sure you like and subscribe to my channel here on YouTube. You can follow me on Instagram at Jack Delora. There will be many tutorials, including many POP-focused videos to come. So stay tuned for those. And as always, thanks so much for watching.